Eric Butler is our talented and dedicated facilitator for tonight's webinar. Eric and I met when we came across each other's testimonies regarding tree removal due to housing development. We discovered that we both share a strong passion for preserving existing trees, particularly those that provide habitat and support the watershed. Washington County is home to a significant number of these trees, but our presence is diminishing every day. Eric has been a steadfast supporter of tree keepers since we first met. Eric Butler is a riparian restoration ecologist with the Clackamas River Basin Council and currently a board member of Tree Keepers of Washington County, providing us with grant writing and technical support. He has lived in various watersheds, including the Clackamas, Tualatin, Yamhill, and Crooked Rivers. He holds a master's degree in environmental science and management from Portland State University and a GIS certificate from Portland Community College. With extensive experience as an ecologist, botanist, and geographer, Eric is dedicated to protecting and restoring ecosystems at the watershed level. In his free time, he enjoys outdoor activities and reading. He volunteers on boards and working groups, teaches environmental science and the value of nature. We're very fortunate to have someone as talented and knowledgeable providing us with this information tonight at this webinar. Thank you, Eric.
Let's see. There we go. So I want to start with just kind of a quick overview of the presentation I've got tonight. I'll start out talking about what watersheds are and what the water cycle is. And this is all information that's really going to help everything after that make sense. And we'll talk about the issues particular to urban watersheds and think about green and gray systems. The center of the talk will be talking about trees as a watershed solution, and finally bringing it home with a lot of best practices, things that you can do yourself. So the first question is, what is a watershed? It's an area of land where surface area drains down to a single point. You can think of a watershed as being a geographical relationship with water. It's all the upstreams of the same downstream. And watersheds are important because they're a really sensible way to think about managing landscapes, whether it's natural areas or urban and settled areas. And the reason this is important is because there's an environmental unity created by the presence of the watershed. And so if you take an integrated approach to managing the watershed, think about environment, society, and economic needs, the watershed scale is really brings a lot of these values together in a way that fits well and is logical. Yes, this is a lot of math, the water balance equation, but this is really kind of the core of why watersheds work and why we need to think about taking care of them. So the variables here, precipitation, or P, is essentially all of the water coming into the system. It's rain, snow, sleet, hail, so on and so forth. And so that's essentially all of the inputs. That water that comes into the system can go out to multiple different places. One of them is evapotranspiration, or ET. So that's water that's returning back to the atmosphere. And the term evaporation is just going directly from water to the air, whereas transpiration is moving through plants. And we'll find out a lot more about why this matters shortly. Q is runoff, or the flow out of the system. This is what's draining into the stream at the outlet. And then there's also storage, which is the amount of water that's remaining in the system. And the change in the storage is the difference between the precipitation in and what's going out through evapotranspiration and flow. Now, in a natural watershed, something that's really driven almost entirely by vegetation, about 40% of the water that comes in as precipitation goes back to the atmosphere, either through evaporation or through transpiration via plants. About half of it soaks into the ground, enters the groundwater, whether at the very surface level or going down to deeper levels. And only about 10% of the water runs off into streams and out of the system. On the other hand, if you have a very urban system, you can see that a lot of the numbers change. There's very little infiltration because most of the ground has been replaced with hard surfaces that don't absorb water. You have a lot of rooftops, a lot of pavements, a lot of tightly packed, hard packed lawns, a lot of compacted soil. So only about 15% of the water goes into the ground, and very little of that goes into deep parts of the water, to deep underground water where it's more stable. And the evapotranspiration reduces as well because there's still a fair amount of evaporation, but you've lost a lot of vegetation. And you can see that the runoff has gone from 10% to over 50%. And this leads to what's called urban stream syndrome. Uh, Urban streams have, you can see on the chart on the right, this is what's called a hydrograph. This is essentially the flow in a stream over time, how the water level is moving up and down with as the water moves into it. So the dotted line is the natural system, and the solid line is an urban watershed. What you can see here is that the urban watershed is actually drier before the rain appears. And then there's this sharp spike of water flowing into the system very quickly, but it also drops off very quickly. The area under both curves, the amount of water actually moving through the system is the same, but it's behaving very differently in the urban system. It's a much faster, much sharper, much starker process. And it's essentially going from drought to flood back to drought rather than a much more stable, continuous moisture. And the upshot of this is what's called urban stream syndrome. This picture on the right is a creek that flows through Happy Valley. The headwaters of this creek are surrounded by large parking lots, urban developments, busy multi-lane roads. And so when water hits this watershed, it moves into the stream very, very fast. And it's carved out this canyon with these vertical walls that are taller than people are. This is very severe erosion. This is about the worst case that I've actually encountered in my life, but this is not necessarily atypical of an urban stream. You can also see that there's a lot of flooding because, again, where you have a lot of rooftops, a lot of pavements, a lot of other hard surfaces, there's nowhere for the water to go. And of course, it's not just water quantity that's a concern, it's also water quality. When you have water moving through very quickly, it's like spraying a fire hose onto the ground. It erodes a lot of soil, you got a lot of sediment, a lot of mud in the water. And get a lot of runoff from road, which has all kinds of contaminants in it, things like motor oil, tire particles, brake dust, a lot of other things that are very toxic. Also get a lot of pesticides and fertilizers coming out of lawns and gardens. You get what's called combined storm sewer overflow. Sometimes if the more storm water is going into the system, to the combined storm and sewer system that's able to handle, then you wind up with sewage backing up out onto the stream. And of course, bigger chunks of things like trash, very spilled chemicals, things like that can also again flush into the creeks as well. Another thing that's doesn't get thought about as much, but it's also very important is temperature. Warmer water is very unhealthy for a lot of native fish and other life in streams. It reduces the amount of oxygen available to aquatic life and also increases the amount of pollution and sediment that can get stored in water. So as temperature goes up, it amplifies all of the other concerns. So what do we do about this? There's a whole spectrum of what's could be thought of as green versus gray infrastructure. A gray infrastructure is kind of the traditional, very engineering-centric approach. You're essentially putting in a lot of concrete, trying to make the water go away, get it out of the system as quickly as possible, send it someplace else where hypothetically becomes someone else's problem. Whereas a green infrastructure approach is managing the water in place. You're really thinking about building a landscape that can handle water even to the point where you're not thinking of the water as being a problem, but rather simply as being a resource. It's something that has a lot of benefits. And if you're able to soak a lot of it in, to slow its movement, to hold it in place, to return it to the atmosphere, to kind of disrupt that to flatten that hydrograph and disrupt that big pulse of water that moves through the system, keep the water in place, that reduces those droughts that happen outside of the stormwater events as well. Having that water around provides a lot of value. And so this is where we get to the idea of what's called a sponge city. If you have more green and less gray, that lets you flatten this hydrograph. It turns these two problems of drought and flooding into one solution. and also makes our water a lot cleaner because this water moves more slowly. It gives a lot more time for sediment and other contaminants to settle out to get filtered through vegetation. And if you're taking a whole watershed approach, you're thinking about everything from the headwaters to the outlet. You're able to integrate these kinds of solutions into the entire watershed rather than just thinking about trying to get the water out of this spot and push it off to another spot. And trees are a really critical part of that. Trees are a nature-based solution to many watershed issues. For one thing, they intercept a lot of water, having a lot of tree canopy, a lot of this very rough surface area up above the ground that's intercepting a lot of precipitation before it ever reaches the ground in the first place. A lot of that evaporates back out into the air, some of it gets absorbed into the plants and transpired. And it's also the interception also filters a lot of contaminants out of the water, even things that's picking up out of the atmosphere. Trees are also helping infiltrate a lot of the water that does reach the ground. The root systems are creating a lot of pore space, creating a lot of openings in the soil. And that's creating more space for its water to percolate into the soil rather than run across the surface. These roots are also adding a lot of carbon to the soil, and carbon is what turns soil into a sponge. The more organic matter you have in soil, the more water it absorbs, regardless of what type of soil it is. Trees are very important for managing temperature as well. They provide a lot of shade, and the transpiration they provide, it also absorbs a lot of heat and returns it to the atmosphere. So if you have healthy trees that are providing a lot of shade and transpiring a lot of water, they're reducing the temperature of the surrounding landscape often quite dramatically. I mean, during the 2021 heat dome, in areas like Forest Park were 30 to 40 degrees cooler than the most tree deficient parts of the Portland area. And of course, trees support a lot of habitat for humans and other wildlife. Having trees around makes really kind of the landscape a lot nicer, a lot easier to pass through for whatever kind of living things are around. And if you have enough trees, enough other vegetation together, it can create what's called a biotic pump. Biotic pump is essentially if you have enough vegetation, have a critical mass of healthy vegetation of the landscape, it actually creates its own weather, even more so than the weather determines what the vegetation is. As the vegetation is producing so much transpiration, condensation, you get the cycle of clouds and precipitation forming over continuous forests or healthy grasslands or other intact ecosystems with good vegetation on them, that it creates precipitation and creates stable weather patterns that don't exist if that vegetation gets lost or degraded. And this makes these landscapes a lot more resilient to drought, a lot less likely to experience drought, makes them more resilient to flooding. It also makes them less vulnerable to fire because the more water is in the vegetation, the less likely it is to burn. That said, trees do have risks that are associated with them, especially when they exist in built-up environments. And urban trees all come with risks, but all of these risks can be managed. And these risks can range from the very low stakes and routine, like your tree drops a lot of leaves every winter, every fall that have to be cleaned up, to the rare and severe, a tree potentially falling over and damaging something. That said, risk is not the same thing as danger. Danger is about Danger is a response of fear and speculation, whereas risk is really about understanding and management. Risk is is the product of the impact, the severity of what could potentially happen, and exposure, which is the likelihood of that happening. And when you approach risk from this standpoint, you can really think about intervening and managing these risks and taking steps to mitigate them, especially early on. So keep your eyes open, look for any issues that might be cropping up, and take early steps that are easier steps and or make it easier to keep your tree around and continue to have the benefits. Tree removal is really kind of a last resort. I see a lot of trees getting taken out, perfectly healthy trees getting taken out after ice storms and windstorms because people are reacting out of a place of fear, even though the tree itself might be perfectly healthy and isn't presenting any particular danger. The risk is still potentially high, but the the likelihood of exposure in this case is very low. And especially if you're doing good preventative care to keep your tree healthy. So getting into best practices, there's a famous saying that the best time to plant a tree is 20 years ago, the second best time is now. All of which is to say, if you have an existing tree, especially big existing tree, cherish it, take care of it. And if you don't have that, that is the time to plant new ones. So think about the right tree in the right place. Um, I want to think about the size, structure, and growth habits of your tree. A bigger tree is better if you have the space. The bigger tree potentially absorbs more pollution out of the air. It has more canopy to provide shade and intercept precipitation. But you do want to think about where other things are in the landscape, what buildings, infrastructure, other kinds of vegetation are around. And you also have to understand that if you have a tree that wants to get big and you're trying to keep it small, you're going to be fighting a losing battle there. And so if you're planting a new tree or if you're trying to work around a tree that's already there, you really want to think about the size of the tree and the size of the space you have available and try to get the right size of tree or the right tree for the right place. Also, if you're buying a new tree, you want to look before you buy. Check the health of the tree. Look under the hood. Are there signs of disease or stress? Is it damaged? If you're buying a tree in winter, in fall or winter, which is the best time to plant, you want to look, are the buds healthy? Are the signs of bud damage? Is the root system healthy? Pull it out. If it's in a bag or in a pot, you want to pull it out, make sure that the roots aren't bound. Now, also really want to be sure that it isn't treated with systemic insecticides that are poisonous to beneficial insects as well as pest insects. Like I said, the best time to plant is really during the dormant season, late fall to early spring. If it's 35 degrees, raining sideways, you're soaking wet, that's the best time to plant. I also want to think about the environment that the trees, and you think about the basic environmental needs of sun, water, and soil. So sun, want to think about not just how much total sun it gets over the course of the day. Also want to think about what time of day it's getting the sun, what the aspect or the lay of the land is. If it's on a south or west facing slope, it's going to get more intensity of sun than it is if it's on a north or east facing slope. I want to think about not just the basic needs of the water, but also how tolerant the tree is of drought or flood conditions, depending upon what your site is like. And even any tree labeled as drought tolerant is going to need some water during the summer months, especially if you have hot, dry weather, and at least until the tree is successfully established. And then also think about the soil. I want to think about the composition of the soil, kind of the sand, silt, clay moisture mixture, the drainage, and the depth. Some trees are very shallow rooted and will do fine if you have soil that doesn't go down very deep. Other kinds of trees need really deep soil to grow well. And so understanding what kind of soil you have is really important if you're choosing a tree. And there's a great online service called the Soil Web Survey where you can look up your address and it will tell you what kind of soil you have and a lot of information about it. Also want to think about the amount of upkeep that comes along with your tree. And this depends partly on the location. If you have a tree that's out in a natural area and you're willing to, someplace where you don't feel the need to clean up after it much, that even a tree that makes a big mess can be pretty low maintenance. Whereas if it's growing close to a house or a sidewalk or overlying a street, something like that, it's going to need more care. So I want to think about things like what kind of mess it makes, leaf, flower, fruit drop, uh, pollen, other thing. Is it going to have aphids that'll drop honeydew? Think about, is it susceptible to pests or diseases that might need to be managed, especially if it's in a location that might be a little more stressful or a little less preferable for that. I also want to think about does the tree have aggressive growth habits? Does it have invasive roots that might heave a sidewalk or crack into water pipes? Might it grow suckers out of the root? Might it sprout a lot of seedlings everywhere? Does it have brittle limbs or branches that might fail on you? And how long is the tree going to live? So for instance, in this picture here, we have sweet gums, which are gorgeous trees. You can see the spectacular fall color in them. Produce a lot of leaf litter, which in an area where you're not worried about them can be great for wildlife, but they're very, very messy. They drop a lot of leaves. They drop these spiny seed pods that could puncture bicycle tires and are unpleasant to walk over. Not a great tree for planting between a sidewalk and a street. And of course, we live in a changing climate, and a lot of trees are particularly susceptible to that. The combination of heat and drought creates what's called a vapor pressure deficit. Essentially, the tree is not able to pull as much water in through its roots as it's losing out the top. And when that happens, that starts killing the water moving tissues within the trunk. And the tree will, once those die, they're unable to recover. That's what's happening to a lot of our Western red cedars right now, for instance. They're essentially losing their water tissue because air bubbles are forming in them because they're losing water out the top faster than they can pull it in the bottom, simply because the air is too hot, too dry, and the tree's letting out as much water as it possibly can just to survive and can't replace it. A lot of trees are also susceptible to air pollution, particularly a lot of conifers or evergreens that don't shed their leaves seasonally. Soil compaction is another very serious issue that essentially suffocates the roots. And then root damage from all sorts of causes, whether it's construction or moving equipment back and forth. Uh, Environmentally stressed trees are also more vulnerable to pests and diseases. That said, there's some trees like ashes that are even perfectly healthy trees are highly susceptible to some introduced pests or diseases. And different trees have different tolerances. And there's an idea called assisted adaptation or assisted migration that's becoming increasingly adopted for thinking about what the climate might be like in coming years and decades and starting to look for plants that are suited to the climate of the future, even if they're not necessarily ideal for the climate right now. And of course, you also want to think about what values you're getting out of your trees. Air quality is another very important one. A lot of trees are very good at filtering out pollutants. Uh, they collect a lot of this material, a lot of particulates, ozone, uh, nitrous oxides, things like that on their leaf surfaces and pull it out of the air. On the other hand, some trees also contribute to air pollution. Some produce a lot of pollen that generates allergies. There are others that release volatile organic compounds into the air that can sometimes make ozone worse. And so that's something else to do some research on when you're selecting trees if those are concerns for you. Uh, Trees, as I mentioned before, provide a lot of benefit for both stormwater management and temperature. And a lot of this has to do with the dimensions and the density of the canopy. Generally speaking, the bigger and thicker, more dense the canopy is, the more of these values it's going to provide. And think about evergreen versus deciduous trees. An evergreen tree is going to do more for stormwater. A deciduous tree is likely to do more for temperature because of when the leaves are most active. And of course, trees provide a lot of wildlife habitat. Generally speaking, a native tree is going to be more beneficial to wildlife than a non-native tree. Hardwoods or broadleaf trees tend to provide more habitat value than conifers. Bigger trees better than smaller trees. Insect pollinated trees tend to be better than wind pollinated trees. And trees that have epiphytes, these are things like ferns, mosses, lichens that are growing on them, tend to provide more of these values than trees that don't host a lot of these. That said, these are all broad generalizations, not hard and fast rules. Then once you've kind of chosen your tree or you figure out the tree that you already have in place, then caring for them. Water and mulch are really crucial, especially as their summers get hotter and drier. Uh, Watering seasonally is needed. Providing a deep soil soak periodically is really a lot better than frequent shallow watering. And this does obviously depend on the root depth, the soil, things like that. And some good low effort options if you don't want to stand out there with a hose for half an hour every night is water bags, essentially plastic sacks that wrap around the base of the tree trunk. They have small perforations on the bottom. So you can fill these up and they will slowly soak into the ground over time. Or if you have timed irrigation, a drip system or something like that, that can also be a real labor saving device for providing trees with water they need. Mulching is also very important. I've had restoration sites that have been very harsh, difficult conditions to get plants established in. And we mulch the plants heavily with arborist chips right away. And the survival I've witnessed in some of these places has been remarkable. Even in a site that used to be a gravel parking lot and had no tree cover on it. The reason mulch is great is because it protects the roots from compaction, from sun exposure. It keeps the soil cool, it retains a lot of water, and it gradually adds carbon and enriches the soil. That said, when you're mulching a tree or really any plant, you want to think a donut, not a volcano. Do not want the mulch piled up against the stem. That invites problems. You want the mulch essentially to form a ring covering the soil around the base of the tree, but not actually biting up against the bark. And like I said, this is especially important when establishing new trees, but any tree can benefit from being mulched. Protecting the root zone is really, really important and very underrecognized. Root damage can be lethal to trees, or even if it doesn't kill the tree outright, it can lead to a lot of other problems. Root damage can be caused by a lot of different things. It can be caused by soil compaction or erosion from moving vehicles or equipment back and forth over the root zone, especially when the soil is wet. And the reason soil compaction is a problem is because it squeezes the air out of the pore space out of the soil, which denies the roots access to both air and water that they need to survive. Tree roots can also be damaged by direct injury from digging or cutting within the root zone, or from being buried under fill dirt, hardscaping structures, things like that, that again essentially cut off the roots from access to the healthy soil around them. And in construction, there are root protection areas that are typically either the drip line or 12 times the tree trunk diameter, although it varies by jurisdiction. That said, the actual area that have roots in them extend out well past the whatever the root protection area is. And so it's definitely good to err on the side of caution, protect more than you think you need to. Some trees like Oregon white oak are especially sensitive to root damage, and a lot of them, even when they're being protected up to standards, are still receiving serious root damage and possibly succumbing over time. And so to protect the roots, avoid the area, especially when the soil is wet. Use mats or boards and moving equipment if you do have to move equipment over the area, because that spreads out the weight and reduces the amount of compaction that happens. If you need to do some kind of construction in the root zone, or if you're planting a new tree in an area where there are sidewalks or other hard surfaces, using something like geocells or structural materials that essentially create a safe space for the roots to grow into, or that prevent that compaction around the root zone. This can be very handy. Then trees require care even after they've become established. Uh, Easy care, like I said, watering, mulching, and also just keeping an eye on them, seeing what's going on, monitoring. These are all easy to do at home. With a little bit of guidance, a little bit of know-how. Planting new trees and doing routine pruning are things that can be easy to do at home, especially early pruning to ensure a good tree structure over time, and also pruning for what are called the 4Ds. So these are any branches that are dead, damaged, diseased, or what I call disagreeing. So branches that are crossing each other, rubbing up against each other, growing into each other's space. And if you get more difficult things, if you have hazard trees that are developing serious pest or disease issues, or ones that simply need major rehabilitation, that's where you want to consult a certified arborist. A certified arborist, by the way, is not the same thing as a tree specialist or a tree care person. An arborist is someone who receives a lot of training and a lot of continuing education, has to meet high professional standards to show that they know what they're doing. Whereas a tree specialist or a tree expert is someone who has a sign saying that they're a tree specialist or a tree expert. It's like I could put on a lab coat and say I'm a doctor, but that doesn't make me or say that I'm a health expert. That doesn't make me a doctor. Another really good thing is leaving the leaves. Leaves are free mulch and free compost. They provide they provide a lot of wildlife habitat, and it's also your excuse to be lazy and not have to do so much raking. That said, there are some exceptions for essentially sanitation issues. Sometimes leaves can harbor pests or diseases that can carry over in the ground and affect the tree next year. This is especially true for most fruit trees. So if you have apples or other kinds of fruit trees in your yard, you want to clean up the leaf litter pretty diligently around those to avoid trouble. But most more kind of wild type trees really don't have these issues. And so if you let the leaf litter accumulate under them, that makes the trees healthier rather than less so. And there are also a lot of other practices that you can couple with trees to really think like a watershed. You can turn your home into a garden. You can turn your rooftop into a sort of tree canopy. So if you have a green roof or green wall, essentially creating a kind of garden bed with a special growing medium and substructure, and you can fill these with a lot of different kinds of plants. Historically, these are usually done with kind of small seed, small succulents, so things like stone crops and hens and chicks. But newer designs can incorporate a lot more kinds of plants. And these have great benefits. Like I said, they essentially kind of turn your rooftop into something that functions a lot like a tree canopy. It's capturing storm water before it reaches the ground. The great insulation, they're very thick and they prevent a lot of heat movement back and forth. They tend to last a lot longer than a conventional shingle or asphalt roof, and they provide a lot of biodiversity. That said, these are special engineered structures that have to be built from the studs up. They're expensive. They're hard. They're especially hard to do as a roof replacement because, again, you really have to rebuild the structure underneath them. And because it is a place where plants grow, they can require some watering, some weeding, some kinds of maintenance. Rain gardens are another great solution. These are that can incorporate trees if done appropriately. And so these are both filtration and infiltration systems. They're capturing rainwater in place, slowing it down, letting it fill up into a pond and soak slowly into the ground where it returns to the groundwater and gets a lot of the contaminants that are coming off of whatever surface they're running off of cleaned out. They're not suitable for all situations, though. If you live in an area that has landslide hazards, or if you have very shallow soils that don't soak up water very quickly, they don't necessarily work very well. And so you want to do some research first, get a professional consultation if you're concerned, if you're not sure if it's a good choice for your spot. And it's the same kind of thing with disconnecting your downspout. You want to make sure that you have the right conditions on the ground to be able to handle that water that's running off. Porous pavement's another great solution. These are various kinds of alternatives to asphalt or concrete that are designed to soak up water. That said, they only drain as well as the ground underneath. One of the great things, a lot of porous pavements are as porous as the soil, as a healthy soil, and they also often tend to last longer. They're less prone to cracking and such. And if you have a wetland or a riparian area, if you have water on or near your property, you have gold. Restore that. Take good care of it. These are the most crucial parts of watersheds because these are where everything that everything that's happening on the dry ground meets the surface water. And any sort of tree planting, any sort of restoration, any sort of soil enhancement in a wetland or riparian area has the biggest impact of any intervention anywhere in the watershed. Riparian vegetation also stores a lot of carbon. Replanting a stream side, clearing out blackberries and other noxious weeds, and installing native vegetation is going to suck a lot of carbon dioxide out of the atmosphere. It's a great climate solution in many different ways. And there's a lot of help out there. There's a lot of people who are working on this. So talk to your local watershed council or conservation district because there are some rules that apply. but there's also a lot of funding and a lot of technical assistance available for this work. And of course, there's increasing well-placed concern about wildfire readiness. And so trees, a lot of the advice I gave above about trees gets somewhat complicated by thinking about wildfires, but it's not necessary, doesn't mean that you have to get rid of all your trees and vegetation and surround your house with concrete to be safe. There's a lot that you can do to harden your home to make your home and other buildings themselves less likely to catch on fire. There's also a lot of about using defensible space, pruning up trees, managing different vegetation zones around your house and other structures, so that you still get a lot of the benefits of having trees and other vegetation without having potentially flammable vegetation right up against your house where it can cause issues. And choosing fire-resistant vegetation. There's a lot of guidance on fire-resistant species that are good that work well in our environment. And finally, this really works again at kind of the watershed or community scale. Talk to your neighbors, work with your homeowners associations or neighborhood organizations. Talk to your city or county government. There's a lot of cooperative work going on right now to really build wildfire readiness into big communities at scale. And it takes champions on the ground to make it happen. It can't just all come from the top down. The Firewise USA program is a good starting place if you're interested in doing wildfire readiness in your community. Finally, it's really important to lead with equity. Where we focus this work matters. You can see this map here is mapping what's called the tree equity score. This is the overlap of the amount of tree cover in an area versus the vulnerabilities that exist in communities to environmental, economic, and social stresses. The neighborhoods that have the least socioeconomic equity also tend to have the least tree canopy. And this is for a lot of different reasons, many of them historical, but many of them are also ongoing. And the communities, what this means is that the communities with the greatest need also present the greatest opportunity to make a difference. And the difference that you make in these communities doesn't just stay in those communities, it extends to everyone. And urban tree canopy is no exception to this. Planting trees in Cornelius has benefits that spread to Cooper Mountain. Uh, tree planting tree planting in Sherwood benefits up in Forest Park. It all fits together. It's all the same one. It's all watershed. So if you want to show your support, if you live in Washington County, you can get this tree friendly habitat sign on the Tree Keepers website. You can also learn more about tree protections in your community and speak up if there aren't any. There's a recently published report analyzing tree policies throughout the Portland metro area and what municipalities have what kinds of tree codes. And surprise, surprise, there are a few pretty significant gaps, as in all of unincorporated urban Washington County. That should probably change. If you want to do something about that, come volunteer with us. And with that, we can take any questions you might have.
Thank you, Eric. People could raise their hands or simply speak up about if you have any questions of Eric. This building is one of my favorites in the world.
But I'm looking at it.
Yeah.
It's amazing.
So Eric, are there good guides to say these are the trees you can plant next to a sidewalk and it won't lift it? Or how do you get these porous sidewalks and so on?
A lot of municipalities maintain those as part of their tree codes. Typically, say I look up the approved street tree list provided by your municipality. If there isn't one, then I would look at neighboring communities. So, for instance, if you live in the outskirts of Beaverton, maybe look at the list that Beaverton or Portland provide. Typically, those lists are based on size and habits of trees. So there are different trees that are appropriate for different sites. So if you're planting in a parking strip between a street and a sidewalk, that means that you're more limited in the kinds of trees that you can choose, because you need something that's going to be short, something with an aggressive root system. If you have overhead power lines, that limits your height. Whereas if you're planting something in a large backyard, the sky is likely the limit. So typically these lists will be descriptive of what are called street trees. So trees that can be planted within the road right of way or close to it.
I know Land Use and Transportation, Washington County has an updated list of appropriate trees to plant there in those areas.
Eric, you talked about some publication about soil surveys, so that you could look up your own soil structure, something like that. What was that about?
It's called Web Soil Survey. I will.
And you also mentioned a publication on tree protections. What is that?
Yeah, that's the report in tree policies that just got dropped in the chat.
Oh, okay. And this is just kind of off the wall, but why really sparked my interest. Why are insect pollinated trees generally better than wind pollinated trees?
That's for supporting wildlife. As a tree that attracts pollinators is going to obviously support pollinators in ways that trees that are generally wind pollinated don't.
And Eric, you had mentioned about the local conservation district. I put in the chat, Washington County's conservation agency is Tualatin Soil and Water Conservation District. And their website is on there too.
But each county has at least one conservation district. So there's Tualatin as a soil and water conservation district is in Washington County. From Clackamas County, it's Clackamas Soil and Water Conservation District. There's East Multnomah and West Multnomah, Yamhill, Marion, a lot of different ones around. There's a Clark Conservation District too, if you're on the other side of the state line.
Does anybody else want to pick Eric's brain here? And we've got a very knowledgeable person. Any questions?
It's very informative.
So if
Makes-
we
makes-
lose so a lot of our ashes to the emerald ash borer, and we have wet soils, what is the best replacement tree?
There's a lot of research being done trying to answer that question. In fact, I think there was just a new publication about that recently. I think Oregon State University put that out. I can look it up in a moment, but there really isn't another native tree that you can just kind of plug in and do a one-for-one replacement on Oregon ash. That said, there are a lot of other trees that do well in wet soils. So depends on your preference with things like cottonwood or
Willows.
willows, red oak or dogwoods, maybe smaller than a tree, but white oak can do well in some places, even with wet feet. White alder is a good option. It's a more kind of heat and drought tolerant alder than the red alders that are struggling right now.
Thanks.
if you have room, a metasequoia does well with wet feet. But they grow big. They grow big.
Well, if there aren't any more questions, should we wrap things up?
Now I have one more.
Good.
So you talked about the importance of mulch for trees. And is chip crop a viable source for that with the threat of things like emerald ash borer?
Potentially. I mean, usually the chips are not getting moved very far. The arborists, for them, time is money. They're not generally going very far out of their way to move material. And stuff that's going through the chipper is, stuff that's going through kind of a commercial grade chipper is getting broken up enough that it's actually killing the ash larvae. So as long as the chips are broken down to less than an inch, it pretty much kills them. So that's also a concern, but it's more moving kind of things that are firewood size or stuff that hasn't been chipped so thoroughly is where you get more of a concern. So if you're in an area with a lot of ash and you're concerned about it moving around, it's your call. But usually if you're getting stuff from the power line tree trimmers or from other reputable arborists, the risk is going to be pretty low.
Well, thank you, Eric. You packed a lot in there and
Yeah.
gave me a lot to think about. I thought I was going to be fairly well versed in this subject, but I wasn't. So thank you.
Yeah.
I learned some new terms. Thank you.
That's very good. Very interesting.
Yep.
Very informative. Makes me think about my trees.
Well, I'd like to put in a little, or maybe Josie, you could put in a plug for our existing trees.
Yeah. So Tree Keepers is right now we're watering trees that are stressed. We're starting at Vos Elementary School in Beaverton, and we're collecting volunteers to help us put the water around and help us mulch after they have been watered. And we're doing that periodically, like weekly. So if you have any interest in helping us out, you'd only need to spend like a couple of hours at the most each watering. And, there'd be a lot of good volunteers around to, have a good time with. So we urge you to join us in protecting these trees. We're starting at Vos, but we hope to, any tree that you happen to see that's suffering from drought, please let us know and we'll try to tend to it with tree watering with our volunteers.
Thank you, Josie. Well, that's a wrap then. Thank you, everybody, for attending. And if you have any suggestions for a future webinar or the format, please let us know. You all know our website. All right, good night and have a wonderful summer.
Thanks a lot,
Okay.
Eric.
Thank you, Eric.
Eric,
Stay cool, everyone.
Is there a way to
And
save the
great.
chat?
The chat's got a lot of good places to go
Yeah.
for information.
Does anybody know how to save chat?
Yeah, I don't know.
Yeah, it'll be saved.
Okay. All right.
Okay, good. Thank you.
Thanks a
Yeah,
lot.
I just saved it.
Thank you.
Excellent. Thank you. Bye.
Bye.